All right, so I'm going to continue with multiplying radicals, but it does get a little bit more interesting here because our factors contain sums, right? Whenever you get addition in the mix, things get a little bit messier. So remember, FOIL, distributive property, whichever you're doing, it all boils down to distributive property. Don't forget that, because sometimes I think people have a lot of confusion just because they don't think about it that way anymore. But I'm not discouraging you from using FOIL. It's fantastic. I use it all the time just because it saves me writing a step. It's just kind of a shortcut. So in this case, my first is 3 times 2 root x. So again, when you're doing this, you can mush things under square roots together, but the 3 is not under a root and the 2 is not under a root. So I'm going to go ahead and multiply those. Say, okay, out in front, I'm going to end up with a 6. That 6 is weirdly giant. 6 root 6 root x. Sometimes I can speak. My outside is going to be 3 times 5, which is 15. My inside, this one's a little more interesting. I get -2, so let's see my inside. Let me move down just a tiny bit. I get -2 root x squared, which again, you have a worksheet about what happens if x is negative. So for this, assume that our variables are positive so that we can just work with the rules and not get too caught up. But I do want you to be aware that there are restrictions on the variable being positive in some of these situations. Here, it's fine if x is negative. You're just going to get back an absolute value of x instead of x when these cancel. But assuming variables are positive, we don't really have to worry about that. What we're going to get is -2 times x. The square root and the square cancel, so -2 times x. And then all I have left is my last, which is -5 root x. Because the 5's not under a root, we don't push it under one, it stays outside. So anything in front of a root should stay in front of a root, anything under the root should stay under the root, unless you end up with a perfect square and can separate that out. I can do a little bit better on this one. I can combine some like terms. So 6 root x's and 5 root x's, those are like terms. And I can just count up. If I have 6 of them, I take 5 away, I'm left with a single root x. I can't really do any better with the 15 or the 2x, so that's where I quit. None of those are like terms. Okay, one more like that. This is really just to remind you to be on your best behavior about distributing. Powers don't distribute across subtraction or addition, right? Exponents and addition, subtraction don't play nice. So we're going to go ahead and say, okay, well, this means root x minus 3 root 2 times root x minus 3 root 2. And we're going to FOIL. My first is root x times root x, which is root x squared, which is just an x. My first, what do I want? My outside. Remember, the things in front of the root stay in front of the root, so it's going to be -3 times 1, just -3. The things under the root stay under the root, but I can mush them together. So a root x times a root 2 is a root 2x, and that would be considered a little simpler than writing them separately. My inside, very similar, in fact exactly the same, just in a different order, -3 root 2x. And then my last is -3 root 2 times -3 root 2. So that kind of works out nicely. I end up with a +9 root 4, right? Which you can absolutely go ahead and simplify right away if you want to. So cleaning this up a little bit, I do end up with 2 like terms. I have a -3 root 2x's, and then I subtract another 3 root 2x's. So I end up with -6 root 2x's. And then this becomes 9 times 2, which is 18. Okay, so I think I'll cut that one here, and next we'll work on some division. Thanks for watching.